Hello, hello. Welcome to a great, grand, glorious day of pre-calculus. Today, we're going to be talking about concavity. This is a wonderful topic about, it's kind of more of a calculus topic. Like, we can't really get into the really, really cool parts of concavity until I get to calculus, which is where it's awesome. But I can introduce you to the concepts so that they're not quite so scary when you get to calculus. And that's the point of pre-calculus, is to make calculus less scary. So go ahead and put away those distractions, pull out those notes, and here we go. So we want to talk about concave up and concave down. So those are kind of our big ideas for this type of thing. And now a concavity describes the way that a graph is bending. So concavity equals bendy. Which way is it bending? Is it concave up? Is it bending up? Or is it concave down? Is it bending down or curving down? So that's kind of the idea here. So concave up, the general shape of concave up is a quadratic with both his hands up in the air. That's our general shape for concavity, for a concave up situation. Now, we can also have concave down, and that is where we have stuff that's bending down. And so it looks more like a rainbow or the negative x squared function. So this is our general shape for concave up, concave down, and all of that great, grand, glorious stuff. Now, we can split this function in half. Right here at the extrema, because we have talked about things increasing and decreasing and all of that glorious stuff. So we do need to talk about what happens, what does an increasing concave up function look like, and what is a decreasing concave up function. And so, because you'll see wording sometimes where concave up is an increasing rate of change. So it's a rate of change, but the rate of change is increasing because it's getting, it's increasing, or the rate of change is decreasing as you go around concave down, which is a little weird and a little wonky, but it's kind of how the phraseology goes future on down the road. But concave up, concave down. So the increasing part is where, remember when we're talking about increasing, decreasing, we have a little dude, that's not a dude. A little dude is starting here on the edge of the graph, whoop, bloop, and he's walking this way. And is he going up or down? So at first, he is sliding down. So that is actually decreasing. So I know that. So right over here, a concave up, but decreasing looks like that. That is, we're still concave up because we're making that cup or the smiley face because it's up. But it's still the decreasing. So as I go from left to right, my function is going down. Even though things are trending up, eventually we will through the curve and we'll start going back up and increasing and all of that jazz. Whereas once my guy gets down here, right, and he's going this way, now he's increasing, now he's going up. So an increasing concave up is the other half of the smiley face. So just that one half side. So we have, for concave up, the shape goes decreasing and then increasing if we have the full entire loop-de-loop. We don't always get the full loop-de-loop, but sometimes we do. All right, so now let's talk about, let's see, what's a nice hand-to-be color? I don't know, we'll keep using orange, Now we have our little dude, and he's starting over here, and he's walking that way, and he starts by increasing. So a concave down, but increasing, is where things look like that. So we're still trending upward because we're on an increasing function, but things aren't getting as good as they once were. So we're not increasing as fast as we used to be. So it's kind of slowing down that growth or those gains. And then once we get up to the top here at that inflection point, and we keep going that way, now we're going down. So that's the decreasing part of a concave down function or shape of the graph. There we go. So we've got the increasing, decreasing, concave up, concave down, and all of that jazz, and just kind of what it's looking like. I'm not going to directly quiz you on, do you know that this is an increasing, Like, you can just keep remembering about increasing versus decreasing, and then keep remembering concave up as your smiley face, which has an increasing half and a decreasing half, and then concave down is a sad face, which has an increasing half and a decreasing half. All right, so just kind of, that's like kind of the key takeaway there. All right, moving on. Let's talk about looking at graphs. Now, is it possible to talk about concave up, concave down algebraically? Yes, but not until calculus. So until then, we're just going to be looking at graphs and trying to figure out whether things are concave up, concave down, and all that fun stuff. When I switch from being concave up to concave down, or from concave down to concave up, then that means we have something called a point of inflection. So that's where we've got the curvature, or the bendiness is changing the trend. So so we could look like something like this, where we've got concave up, and then it switches going to concave down. So that's technically the point of inflections right here, where those two things meet. It could also go this way. We could have something that starts going this, but then finishes up going like that. That's also that point of inflection right here, where I switch from concave up to concave down, or from concave up that way to concave down that way. Like, there's all sorts of weird wonky ways that it can go. So the point of inflection is inflection means we're switching bendies, bend direction. That's what inflection is talking about here. Inflection means different things in different places, of course, because, English language is fun. But that's what it's talking about right here. So kind of think about it as kind of like your extrema, where we would switch from increasing to decreasing at a max or a min. This is a point of inflection where I'm switching from concave up to concave down. So first up, we got to figure out where our concave ups and downs are. Like, what does this look like? And then we can kind of find our points of inflection. So concave up, starting out, I have my little dude, right? He's starting over here. Here's my dude. And okay, we're decreasing. Right, but are we decreasing? Does our decreasing look like this? Or does our decreasing look like this? Because this would be concave up, and this would be concave down, right? So let's kind of draw that graph out again. So we have this way, which is decreasing, concave down. And then we have this way, which is increasing, but concave down. And then we have, let's see, this way, which is decreasing, concave up. And we finished that up, and we have increasing, concave up. Okay, so looking at this piece, we are decreasing, but we're not like going down a hill, like we're kind of coming down to the bottom of the hill, not going up over the top of the crest of it. So this part right here is concave up, because it's kind of curving up, making a smiley face. Like, if we finished up that curve, we'd have a smiley face. But then right there, at that -2, 1, or somewhere thereabouts, you do not have the tools to figure out exactly where a point of inflection is, so you're going to have to eyeball it. And I'll try to label the points as needed for the stuff and things. So right there, we're switching, and we're no longer making a smiley face. We're now kind of drooping off the other half of the mouth, and now we're still decreasing, but we're decreasing in a concave down fashion. And then right here, or thereabouts, we're still decreasing, but we've switched and things are kind of trending upwards until we get to about here-ish. And then we're doing our concave down thing up through here. So we've got a concave up, concave down, concave up, concave down, all of that stuff thing. So those spots where we switch from one to the other, those are called points of inflection. So this guy, and this guy. We got 3 of those points of inflection, so let's write those down. -2, 1, and 0, 0, and 4, 0. They're not always the intercepts. Sometimes they're the zeros. There are other places too. But that's how that one checks out. And then so concave up, we went, and again, just like with the intervals of increasing, decreasing, we're looking at specifically the x values. The y values are telling me, like, kind of, am I increasing or decreasing? Am I positive or negative? But the addresses that I'm looking for are the x values. So from -4 to -2, we're concave up. And then we switch to being concave down. And that's from -2 to 0. And then we're switching to concave up again. And we're going to go from 0 to about 4-ish. That's what we're going to go with. And then we're going to go from 4 to 6. We're concave down. I don't want to include the in brackets. You aren't technically wrong if you put square brackets on here and here. It's just kind of awkward, and we'll just stick with parentheses all the way across for this level of mathematics, and you're fine there. So from -4 to -2, we're concave up. We're kind of making that smiley face, and then it turns into a sad face, and then does the full smile, and then does this full sad. And that's what this graph is doing for concave up, concave down. Let's look at another example, because, you know, picture's worth 100 words. Let's look at another one. Yay! Yay! All right, so starting off, let's see. I don't know. This guy almost feels like he's linear, right? Let's take a look at that. If I go up 1 over 1, 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 up 1 over 1. Yeah, that's actually kind of linear. And fun fact, linear things aren't bendy. They're actually just straight. So I have to have a curvy line to have a curvy bit. So I'm actually going to say that like through there, there's not going to be any concavity. We're going to pretend like he's part of the concave down part. But if you said, no, there's not really anything going on there, and then I have a point of inflection at 0,3, you're not wrong. That really does look like a straight line. Is that a straight line? Let's see. If I grab my ruler. Well, okay. It's got a little bit of a bend to it. Maybe I'm just not putting this thing at the right angle. No, that's pretty straight. Okay. All right. Bad example on my part. Sorry about that. So we're going to pretend like concave down, but really the concave down starts here and goes to about, again, that part through there, somewhere in here, somewhere in there. You, again, don't have the tools to really talk about where in here you're switching from concave up to concave down or from concave down to concave up. Pick one of the 2 points. On the test, I'll try to make it fairly obvious and I will make sure to label the point of inflection. It'll be one of your labeled points. Yay! There will be other labeled points too, so don't just go, oh, that one's labeled, so that must be a point of inflection. I might throw in red herrings where I label the point just for kicks and giggles, not because it's actually useful. All right, so point of inflection, we've got, I'm going to go with 4,3. We'll call that a point of inflection. And then I think we've got another one at 10,0, where we've got that, we're switching from being a smiley face to a sad face. Right, and then concave up, that's going to be this part through here. But then I said the point of inflection was up here. So I'm actually going to include all of that in my concave up. So from 4 to 10. And then concave down, we're going to go from, I hit the wrong thing. Try that again. There we go. 0 to 4 and 10 to 11. And we'll just pretend like this part of the graph isn't there. There we go. There. Now it's a nice, happy graph. Yay. Okay, moving on. Turning the page. I want to talk about just kind of a couple of other things that we need to discuss with stuff and things and whatnot. So one of the things I can give you, so here's the function f of x is equal to x cubed plus 3x squared. Here it is graphed out in Desmos. And one of the things that I can ask you is, where is f of x greater than 0? Or in other words, where is it positive? So to do this, so where is it positive, i.e., so f of x, remember, f of x is the y values or the outputs of my function. So where are my outputs positive? So let's see, I've got, oh, I want green. So I got positive outputs here. And I have positive outputs here. Question, is this 0 right here, is that guy right there, is he positive? Is he greater than 0? No, the y value right there is 0. It is not greater than 0. So I technically have 2 intervals where things are greater than 0. I've got from -3 to 0, and then I've got from 0 to infinity. Those are my 2 places where things are greater than, or my outputs are greater than 0, or where my outputs are positive. If I'm looking for where my outputs are negative, that's this part over here. So that's going to be from negative infinity to -3, and that gives me my negative parts. So that's my positive and my negatives. And then I can talk about intervals of increasing, decreasing. So let's take those color highlights off. Intervals of increasing and decreasing. So I'm increasing, right, all through here, and then I'm increasing here. And then that space in the middle, I'm actually decreasing. So putting those on my stuff things, I've got increasing from negative infinity to -2. I'm decreasing from -2 to 0. And then I'm increasing from 0 to positive infinity. So that's that one. All right, the other thing that we can talk about looking at a graph that's counted in intervals is where are things concave up, where are things concave down. So concave up, smiley face happening there, concave down, sad face. I really should have picked, you know what? Here, hang on. I'm gonna change the color. That's better. Easier to see, doesn't eat things. Okay, and that's where things are concave down. So concave up goes from, looks like the x value there is -1 to infinity. Again, for all of these interval things, I'm curious about the x value because that's the address. And then -infinity to -1 and blah 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 blah. Okay, so yay, I've got my positive, negative, I've got my intervals of increasing, decreasing, I've got my concave up and concave down. Now, all of these things have borderline points. So just to talk about that real quick, in between positive and negative, so right here, I have the points that I care about, my points, I care about zeros. So the zeros of this function, or x-intercepts, we'll do x-intercepts because I'm actually wanting to talk about the points. So x-intercepts, so my x-intercepts are -3, 0, and 0, 0. Now, usually, quite often, especially with polynomial functions that are nice and curvy like this, the x-intercept is where I'm going to be swapping from a positive value, stop it, hey, stop it, where I'm going to be swapping from negative values. So down here I've got negative, 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 or for all of these x values I have negative things. When I hit a 0, I swap from positive to negative. And then right here, when I hit the next 0, I could swap down to negatives again, but instead this function turns around right there and stays positive. So that's my zeros, looking at things being positive or negative. Now, I also have intervals of increasing and decreasing, and for those ones, my swapping point between increasing to decreasing, this is my extrema, which remember is another fancy word for max and min collaboratively. They're collectively called an extrema. So that happens, let's see, I've got an extrema here, I've got an extrema here. So that's where things can swap from increasing to decreasing. So if I'm looking at increasing, decreasing, right through here, my function is increasing, right? We're going up, we're going up, we're going up, 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 until here. And now I'm switching to decreasing until I get to this extrema, and then I switch back over to increasing. So I can have negative, positive, increasing, decreasing. I can negative values that are increasing, and I can have positive values that are decreasing. And then the other thing that we have is this concave up, concave down, and we've kind of already talked about that one. Let's see, what color should I use? I've kind of used all of them. We'll use green. And for this one, my point of inflection is the thing that helps me determine what's going on there. So my extrema here, let's see, I had switch this back over to red. I had a max at -2, 4, and I had a min at 0, 0. My point of inflection here is -1, 2, because that's where I'm switching from concave down to concave up. So I can have, for my concavity, this is concave down, right? It's this shape all the way across here until I get to here, and then it switches to concave up, and now I'm curving upwards for all of the stuff and the things. So we have these different things that we can talk about. Positive, negative, and then zeros is where we switch between those things. We have increasing and decreasing, and then extrema, maxes and mins, that's where we switch between those. And then we have concave up, concave down, and point of inflection is where we switch back and forth between those two things. So just all of these kind of things tied together, and we can look at one graph and we can talk about all of these different things. So here's another function. We've got f of x is equal to x squared minus 2x minus 8. So a nice happy little quadratic. So real quick, let's go through, do the intervals. Where is it positive? Where is it negative? So positive and negative, that just has to do with the really truly, where is the x-axis? Things above the x-axis, those are positive. Things below the x-axis, those are negative. Okay, so I've got positive, 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 all the way. Oh, hit the y-axis, or I've hit the x-axis. So now I can swap, and I did. and I've got negative values, and then I hit the x-axis again. Okay, now these guys can be positive. So my positive values are going from negative infinity to negative 2. My negative, the interval of negative outputs goes from negative 2 to positive 4, and then I have another interval of positive outputs from 4 to infinity. Okay, and then I can look at things from an increasing or decreasing standpoint to figure that out. So let's see. Oh, let's write the zeros. Zeros are negative 2 comma 0 and 4 comma 0. So before we go for increasing, decreasing, let's find the extrema. I have one at 1 comma negative 9, and it is a minimum, right? Which means whenever I have a minimum, I have decreasing on this side and increasing on this side, because it has to come through and do whoop, like that. So my increasing function, so things are going, will you stop that? Up, 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 and here they're going down, 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 because I'm decreasing. So my decreasing is going to go from negative infinity until that extrema, which happens at 1, and then my increasing, and then I switch over to increasing, and I keep increasing forever. Quadratics only ever have one extremo. They only have the one max or min. I think we talk about that later in the course, but for right now, we'll leave that there. All right, next up, we have a point of inflection. So where does this thing switch its curviness or its bendiness? It turns out quadratics don't flip their curvature. They're either a smiley face or a sad face. They don't get to pick. They don't get to flip-flop between the two. They're one or the other. So in this case, I have a concave up from negative infinity to positive infinity. And so my point of inflection is none, and my concave down is not applicable, or none, because it just doesn't happen. So we've got the flip-floppy happening at 0. So yeah, recapping. Zeros tell me where I flip-flop between positive and negative. The extrema tell me where I flip-flop between increasing and decreasing. Points of inflection flip-flop between concave up and concave down. You don't always have a point of inflection. So sometimes it's just always concave up or always concave down. Last example, we have this beautiful function here. And so, well, okay, so we're going to go through the same process. Where is my function positive? Where is it negative? Greater than 0, less than 0. In order to do that, I have to look for my zeros, which happen at positive 1.5 comma 0. Oh, my word. And so that's that whole thing. So on one side of this, I'm going to be positive, and on the other side, I'm going to be negative. So in this case, I happen to be positive from negative infinity to 1.5. Or maybe I'm negative on both sides or positive on both sides, you don't know. But that's where I start looking for interesting things happening in regards to whether things are positive or negative. I have to find the zeros. All right, and then, or x-intercepts, sorry. I should be calling those x-intercepts. Hopefully I'll remember to fix that on your handout before I give you this video. But, you know, life happens, and I'm not hopeful. So I'm hopeful, but not very hopeful. Extrema. Okay, so there are none. None. A linear function is a straight line. It doesn't have a point where it turns around and starts going back the other direction. It is just a straight line. So it's either always increasing or it's always decreasing. In this case, we are always decreasing, negative infinity to positive infinity, and there are no intervals of increasing. Straight line. Straight line's not bendy. It's not curvy. It can't be concave up or concave down. So it's not really applicable to have a concave up, concave down, or points of inflection. So that's just NA across the board, or none, whichever things you want to do for that. All right, that's enough for this video. Let me know if you have any questions, concerns, comments, or queries. This whole thing about flipping from positive to negative, increasing to decreasing, concave up, concave down. What is concave up? What is concave down? And just, yeah, that's kind of the main things that we talked about in this video. Let me know if you have any questions, concerns, comments, or queries, and happy mathing!